Hey, what's going on? Welcome to ngAir. I'm your host, Justin Schwarzenberger. And on today's episode, we are going to be learning some more about schematics. So some tooling should be pretty exciting. Looking forward to it. Let's say hi to our panelists, then we'll meet our guests, and then we'll get right into the content. Joining us today, we have Bonnie with us. Bonnie, what's going on?
Whole lot of nada. How are you doing?
Doing great, doing great. How about yourself? Oh, internet connection, maybe frozen. But I was going to ask her about her new plant. Oh, how's your new plant?
I love it. I love it. It's just yeah.
Nice.
Does it have a name or just plant?
It's a monstera. I think I'll call it Mike Rocky.
All right. All right. Mike's with us. Mike, what's going on?
Hi. I'm not sure how I feel about being called a plant or having one named after me.
You should feel honored, Mike.
It's honored.
I mean,
Right?
it's not like a key to the city or anything like that, or key to like anything like that. But I'll take it. I'll take it.
Close.
All right. Alyssa's with us today.
Because it's a monstera, and you played a Cookie Monster in Shy Resnick's play, so it's all connected.
I see. Not really, but I'll say I see.
There we go. Just accept and continue, right? Alyssa's joining us today, here to help us answer the questions that everybody wants to know the answers to, like the name of the plant. How's it going, Alyssa?
Oh, it's so good to be here. Happy Turkey Day for the States folks, and happy day before Thursday for everyone else.
Yeah. All right, and our guest today, Kevin's joining us. Kevin, how's it going?
It's going great. Glad to be here. Looking forward to talking about schematics a little more. As we were talking about earlier, you can never know enough about schematics.
For sure, for sure. We're excited to have you here. Do you want to tell our viewers a little bit about yourself so they can get kind of caught up, know who you are?
Sure. Yeah, my name is Kevin Schuchard. I live in Broomfield, which is just north of Denver, Colorado, and I work at Breebug. So I'm a developer there, and I get to work with some really cool clients while at Breebug. And I've spoken a couple times on schematics, mostly with Mr. Brian Love, which I think we all know here. So yeah, we
love B-Love.
Yes, who doesn't, right? Who doesn't? So
I don't want that to take away. We love you too, Kevin.
Oh, well, thank you. Thanks. Yeah. So yeah, I've written a few schematics. I've got a chance to really try a couple different things out with them, and hopefully I can share some of that knowledge today and get some people excited about writing schematics.
You sound so cool when you say that. I've written a few schematics in my time. Like, oh, really? Really? Okay. And you're going to show us?
I didn't say I written a good schematics. I've just written some. Yeah, so we can maybe take a look at a few that I've written, but yeah, there's lots of great ones out there though right now. So it's exciting to see. It's been exciting to see them kind of really come alive, because it's still somewhat of a new thing, and I think there's still lots of opportunities for people to write schematics for a variety of things, which we'll hopefully talk about today.
We were seeing that Anthony Cypress schematic all over Twitter. Was that yesterday? Yeah,
so I think he just.
Now.
It is hot topic. Yeah, Anthony Jones, who works with me at Breebug, he just released a new update for his Cypress schematic. So previously the schematic would kind of set everything up to run your end-to-end tests with Cypress versus Protractor. It would kind of swap everything out, but it was relying on the package JSON scripts once you got that thing set up to run. So he recently added the addition of a Angular builder. So it still sets everything up for you with the schematic, but it also provides the builder so that you get to use the CLI to execute the Cypress tests. So that's very cool. Yeah, that's live and out there today. And Anthony's, I think,
Twitter handle?
Yeah, his Twitter is Anthony Jones 519. And then for the schematic itself, if you just go to the Breebug GitHub, you should be able to find the schematics. That's BRIEBUG.
Can I do lazy web question?
Yes.
Does it like rip out the existing Protractor stuff as it puts the new stuff in? Does it, or does it just leave it there?
That sounds so violent. Just
Does it gently remove the
Yes.
protractor stuff?
I believe it does. Anthony's done pretty much all the work on that, so I haven't dove into the guts of what it does. But if I remember correctly, I think it does remove, because I think he prompts for it with the CLI prompts.
Okay.
If you want to remove it.
That makes sense.
Very cool. So I know you're going to be sharing some stuff about schematics. Do you have plans when you're sharing your stuff that to cover like the basis of what schematics are, or should we talk about that right now before we get into any type of presentation?
Yeah, good question. Yeah, I have a slide on kind of what it is, like a definition that we can walk through and hopefully get a good baseline of what schematics are.
Cool. Then I won't ask about it right now. Perfect. Sounds good. Well, do you want to get into that?
Yeah, so I can share my screen. I've got a slide deck ready. This thing load up.
All right, we're set.
All right. This thing finished loading. We'll just get into it here. So like I said, my name is Kevin Schuchard. I work at Brebug. My Twitter handle is my full name, which is kind of hard to remember, but there it is, Kevin Schuchard. And I also have write some blogs at kevinschuchard.com. So you can find some of my ongoing projects there as well. So a quick little history of how I got started with schematics. I knew absolutely nothing about schematics, like I'm sure a lot of people either did or still do. But Jesse Sanders came to me one day and was like, "Hey, I've got this idea. I want you to write a schematic that will set up Jest to work with Angular with a single command." I'm like, "Well, that sounds great. I guess let me learn about schematics. What is a schematic first?" I'm sure everyone knows that Angular comes with Karma and Jasmine to run unit tests, right? And Jest is kind of an alternative that packages that up, and then lets you kind of do a couple things that Jasmine doesn't really do. So I took a couple days and just kind of dove in. There was a really great article, fortunately, that Hans from the CLI team wrote that kind of laid out getting started with schematics. So I read that probably 50 times and just started plugging away, and eventually got something that kind of worked and then kept hacking away at it and got my first working schematic. So that was kind of my first deep dive into what schematics are and what they can do. And it was really inspiring because I was able to take like an idea or a process or a pattern, something that someone wanted to do that was somewhat deterministic, right? There's not a whole lot of room for how you go about setting up Jest, but at the same time, it's also not just a single command, which I think we often all kind of hope we could have depending on what we want to do. So that was a real exciting first project to take on. And then I started thinking shortly after about that, and there's a lot of things that I do on a daily basis that are repetitive. They're not necessarily difficult, but I certainly don't hold that in my short-term memory about how to do or how to set up. And Prettier was one of those things. So Prettier is like an opinionated code formatter, which you may or may not like, but I'm a big fan of it. And I kept finding myself setting that up over and over again with all my projects. And I would go find the same article written by Aaron Frost. Fortunately, he kind of sat down and at least put that all out into print form about here are like the 10 steps you need to do. And at the time, and still is, you can't just say npm install Prettier and it works with Angular projects. You need to do some setup. So I, again, took some time and said, okay, what are all these steps? I kind of just took Aaron's article and basically translated his blog post into schematic instructions, if you will, and created probably one of my favorite schematics that I use on almost every project. And now it's just as simple as ng-add and then my schematic name. And I now have Prettier set up and running just within a few seconds. So that was
awesome. Is that available anywhere for people to use? Do you have it up online?
Yeah, definitely. It's on my GitHub and npm, and I'll have a link at the end that we can kind of look at where I've kind of packaged up a lot of the schematic things I've learned and resources, and that's on there. But yeah, it's just ng-add and then at Schuchard/Prettier schematic, I think, or Prettier, I can't remember. But yeah, it's publicly available, and I use it. I just used it yesterday.
I want to take a moment and pause, and first of all say thank you for that. And also, I think it's awesome that you have your own NPM scope for yourself. That's all.
And I want to say your last name is actually much easier to remember if you just remember the CH and the CH each time. There's a CH each time. So SCHU.
Yeah, my last name is I've gotten that my whole life. I usually just let it go when it gets butchered, but yeah, that second
Well, you
C.
have to know how to spell it to find that awesome GitHub repo. So you see.
I know. Yeah, you're kind of forced to learn it, I guess.
It's worth it.
Yeah. Yep. So yeah, that package is available and is out there and still works as of yesterday when I tested it out. But that one really drove schematics home for me of like, okay, this is something I'm tired of doing, tired of repeating myself over and over. And I'm sure other people are setting this up. So like this was a way I could help myself and help the community and kind of save us all, an extra 15 minutes to an hour setting this up on projects over and over. And then very fortunately, Brian Love and I gave a talk at ngConf and a workshop on schematics, and was very fortunate to go there with Brian and do that. And that was a really exciting opportunity to talk about schematics at the ngConf conference.
And is that a video that's online available that people will be able to check out?
Yeah, just like with all the other presentations and workshops, ngConf has graciously put those up on YouTube. So if you go to the ngConf YouTube, I think I have a link somewhere to that, but I can get that for everyone. But yeah, those are on YouTube and free to watch. So Justin, you talked about a definition, right? So I think it's always a good starting point to make sure we kind of all understand what schematics are and what they do. And this is a kind of a definition that Brian Love and I came up with, and I think it really nails schematics pretty well. So I like to think of schematics as a collection of executable tasks that can generate and or modify code deterministically, right? There's a couple things in there that are important, right? They're a collection because you can have more than one schematic or executable, right, within your overall schematic. So within, like, for example, my prettier or the Jest schematic, we can have individual schematics that run. So typically there's usually like one or two, right? There's like one that supports ngAdd or maybe another specific command, but you can have a schematic that has basically a collection of executable tasks within inside of it. And we say that they're executable because obviously the Angular CLI engine or the schematic engine is what is going to be executing or running these. So these are not going to be like a script per se that you're going to run directly from the, like the package JSON scripts. Although you could, I guess, shorthand that into a script, but ultimately you're going to have to run the ng command and have the Angular CLI executable run this for you. And then
so this is something that's like, we need the Angular CLI to be doing the schematics thing, right?
Yes, technically you can. There is a schematic CLI. So you could, I guess, technically execute it in that context. But for 99% of the time, and people, I think everyone's going to be using the Angular CLI. So you're going to need that to run your schematic. You're not just going to like SH it or run it directly.
Yeah, and that's a very good point about there being a separate CLI. And typically, being that schematics comes from the Angular team, that it's going to be used in an Angular context. But there's nothing to preclude anyone who may be doing development in a different language to write schematics. So if you're doing C# development or Java or anything else, you can still write schematics to be able to generate your code for those environments as well. There's nothing tying it directly to Angular.
Yeah, great point.
And then kind of the examples that you showed in the beginning were things that we're adding to a new project, right, or an existing project, right? But so it encapsulates being able to do that, but also if I have an existing project that I want to modify code or do things like that, that as well, right?
Yes, absolutely. And so there's it's a really broad scope of what you can do with schematics, because as we'll talk about later, you get access to the abstract syntax tree, or the AST, of the repository, or the basically the folder you're executing this within. And then it's really up to you how you want to either read or modify or update or delete or add. I mean, you can do pretty much anything within that code as long as you can programmatically lay the schematic code out. And really the sky's the limit as to what you want to do. So the things, the additive features are actually quite a bit easier to do, and oftentimes I think that's why there's more of them out there, because it's a little less code and side cases that you have to account for. But you can definitely generate and or modify code. So we'll see in a little bit. Generating code is actually pretty easy once you get everything set up in the schematic. You can kind of stamp out a lot of files pretty quickly. But we can also modify that. So we'll have access to the AST. We can read the file system, and then we can make whatever decision our schematic needs to make, whether if we're checking for the presence of something, or we're rewriting something, or moving something. We can have complete access to that and make those changes to the file system that the schematic's running against. And I think one of the most important things, schematics are deterministic, right? So this is not like a string matching library or function that we're writing. We're not saying, find this exact pattern or string. We're not writing a regular expression. We're using the AST to get very precise information about the code that we're looking for, so that we can make updates that are very exact and very precise. So we don't have to say, like, find this specific opening brace, and is it at the right level? Am I looking at an import statement versus a constructor? Right? We can loop through the nodes of our AST and find things not only by their name, but also by their type, which I think is very powerful. So definition, pretty good, hopefully, I think. But I think a lot of people aren't always aware that they're kind of already using schematics, most likely, if they're using the Angular CLI kind of in a day-to-day manner. And so if you've ran the ngGenerate or ngg command within the Angular CLI, that is using schematics. And so there's a ton of really great schematics that the Angular team has put out, right, for things like generating a component or service or pipe directive. Right, these are things, if you're not using them, I highly recommend you go and look at them and start using them, because it makes generating this code very easy. But the Angular CLI is provided these for quite a while now, and it's actually been a great resource for me learning schematics. That was probably where I spent most of my time learning, like what are kind of the best practices, if you will, or how is the Angular team doing this sort of thing? Because once you start writing them, you'll see that there's kind of some repetitive functionality that you kind of need to do, like finding modules or inserting code and so on and so forth. All right, so let's talk about what could we do. How can we write schematics? What can we write them for, right? So we talked about adding files, and I think this is like the first real win you'll experience when you start writing a schematic, right? When you can quickly kind of stamp out a bunch of files very quickly. And so one of the methods that they provide is in a schematic, you can pass it a directory in your schematic source code and kind of predetermine the structure or the files or the file names that you want to add to a application when you're running the schematic. And so if you've run ng-new, right, and give it a project name, you'll see like the create word followed by all these files. And so this is where the schematic's adding all these files for you. And then once we have those files, most of the time, right, we're going to need those files to be dynamic in some way. Sometimes those can just be static and we can add them as they are, but most of the time we'll probably want to put some sort of dynamic, either functionality or name or so on and so forth. And so this is a very slimmed down snippet of the ngGenerate component source code in the schematic file. And so I've taken a few things out. So if you're comparing this one-to-one, it's going to be a little different, but these are kind of the main parts here. But we can see, similar to Angular, where we have the double curly brackets, we can interpolate files within our schematic with this kind of less than percent equals and then percent greater than syntax as well. So we're kind of wrapping the interpolated value in that syntax. And so here, whatever we pass in for that selector value to our template, right, it'll be dynamically interpolated in that place with the single quotes around it. And then within that, we can also put some more logic in there. So here we have those same wrapping keywords there, or syntax, and we can put logical statements in there. So the Angular component schematic does some kind of smart things where it says, well, if you want inline templates, right, then we'll add the following code, right, the template colon, and then that string there. Otherwise, right, we'll add it a different way, right, a template URL, if you will, which I've taken out here. But we can add conditional logic within our templates.
It looks like PHP. I was thinking
Does
that,
it?
and
That's
then
right.
somebody in the chat said it too. It was like, it reminds me so much
Close.
of PHP.
I think it needs a question mark, right, instead of the but really close.
Yep, very close. And just like Angular, right, we don't have to put all of this logic in our template, if you will, our file template, as we're looking at it here in the context of a schematic. And so we can also pass methods into that template context so that we can pull some of this logic out of the template file and put it back back in TypeScript land and either share it or unit test it that way, or however you want to do it. So we can pass dynamic properties into the helper templates or helper methods and pull that logic back out and still get that dynamic nature in our template files. And as you'll see, we have things like dash, rise, and classify. These are good examples of kind of common features. I don't want to say problems, but things that you'll come across that it's again good to go look at other schematics like the Angular CLI schematics and kind of see how they're doing those things, because the dash, rise, and the classify string method, like that's not something you want to write yourself, right, or rewrite, or maybe get it right or wrong, right? There's lots of that's kind of been solved, if you will. So I highly recommend looking at some of the other schematic libraries out there and see how they're doing it or what they're using.
Those helper methods always make me giggle every time I use them, because I think they have the best names. Dasherize and classify.
Yeah, there's no doubt what they're doing, right?
They sound like reindeer.
That they do. And lastly, just like we can interpolate the contents of those files dynamically, we can also do that with the file names. And so this method or this pattern looks a little bit different, but you can see we can use this double underscore, provide a variable, in this case name, and then apply those methods to that string name in the file name. And so here, if we go back a few slides, when you run ng-new, right, everything kind of gets generated for you dynamically within the file name itself or the folder. And so that's kind of what's going on here, where we can dynamically generate these file names based on either what the user's passed in or however we want to modify it.
That's a really good point, that it's not just the file name, but you can also alter the path of where those files are going to be generated. Yeah, great point. I mean, we have kind of TypeScript control all the way down up until this point, so we can either look at where it's being executed or any other options that we want to tag onto that name variable. So another great tip I found is that you can extend schematics or execute other schematics within your schematic. So a schematic that runs a schematic, if you will. And so there's a method called external schematic, right? And it takes the name of a schematic collection, right? Then this specific schematic, and then any options that you have. And so I think this is really powerful if you have a schematic in mind that kind of does maybe most of what you're envisioning for your kind of potential new schematic, but not quite everything, right? Like, let's say we want to, make a new component, like similar to the ng generate component, but we want to maybe add a few things that maybe our company kind of always has, or maybe we're
trying to do some sort of pattern like the ng on destroy, RxJS subject cleanup pattern, right? So instead of writing all that code to generate a schematic, right, you can execute an external schematic, for example, the component schematic that Angular provides, right? And then just kind of tack on your changes on top of that. And so you can kind of do that approach, or maybe you've got like a new project approach, right? And you kind of keep executing the same 3 or 4 schematics. You could kind of bundle that up with the external schematic command.
For examples like that, do you override the old schematic call out, or do you make your own name for it whenever you're tacking on things?
I'm not sure I follow the
So
question.
you were saying, if you want to create a component, but then you want to add another schematic on top of that, do you override basically the ng new component terminal command, or are you creating your own command name, I guess is what I'm saying?
Gotcha. I think in this scenario, this would be like creating your own schematic. So it'd be like, whether you namespace it or not, but like your, component on destroy schematic or something, right? So you'd be creating your own, and under the hood, it's just using the Angular CLI schematic. Right, updating files. This is where things start to get a little fun, if you will. But once you get into schematics, right, you're only going to get so far probably adding files, and at some point you're going to want to update one.
Can I add something in real quick before you
Yes.
get into that? Is
Please.
that what you're getting into here with the AST and taking a look at that? It's a smarter way of doing this, but you are not necessarily tied to doing this directly. You don't, as you're writing your schematic and you want to modify a file, if you are, for your use case, if you just want to do a regex replace, or if you want to do a search and find of text, you can do that as well with schematics. This is just taking those types of concepts and raising them to the next level to give you that extra level of assurance when you're modifying code.
Yeah, that's a great point. And thank you for bringing that up. So this is not the only way to update a file. It may be a more maybe in a more exact way if you're a little more unknown about who's going to be executing your schematic or what you're trying to update. But you certainly can, I think a common pattern can often be if you're dealing with JSON, for example, the package JSON, if you wanted to modify that, sometimes it's easier just to get that in a string format and parse it with JSON.parse. And then you can deal with an object just dotting into properties or overriding things. And then you can stringify it back out and run a TSLint formatter to get it back and formatted. So it's not required for all updates, and that's a very good point to bring up. But once you realize that I need to use the AST to get this done, I think that's the best way, right? You're going to start dealing with your code kind of in this format. So here's kind of a simplified example, right? But we're typically dealing with nodes of the AST, and we'll look here in just a second at what that kind of looks like. But the AST, right, will give us this representation of our code. So code that describes our code, and we'll be able to go through that and find certain things, for example, such as the opening brace token or the closing brace token. So in this example, we probably would have found this node based on some other identifier, right? Like the constructor identifier, right? And then find the opening and closing braces within that. But we can, as you can see, very precisely find exactly what we're looking for. So we're not just saying like, well, I think this is going to be the opening brace of what I'm looking for, but there's also 50 other opening braces, right? And so this just helps us be a lot more precise in what we're looking for. And then once we have those things, typically within a schematic, the code that your schematic is working against is kind of referred to as the tree, right? And so you'll kind of begin an update, you'll make your insertions in this example, right, based on the position, right? So the AST is going to give us positioning info, and then we can make our assertion, commit it, and then our schematic can carry on. And the committing part is interesting because schematics they are kind of building these changes that your schematic code is making, such as like adding, updating, deleting, right? They're building these up kind of almost like in memory. And so that, let's say your schematic code got like 10 steps in, right? And it didn't account for something and just blew up. You wouldn't leave the user kind of in this broken state where it's like touched a bunch of files and deleted some. And then it's like, well, the thing exploded and you can clean it up, right? So we're kind of beginning and committing these updates, and it does it in memory, which is really nice because we don't have to have any unwinding logic within our schematic to kind of backtrack. So if it stops halfway through, right, it's not going to apply those changes until it gets to the very end.
Just to close that loop, and I've used this example a lot of times, and I've said this quite a few times, is that idea of doing it in memory is kind of like, wait, what? And some people have trouble wrapping their head around that concept. So it's very, very similar for those of you who have done traditional database development to a database transaction, where if you do any updates, deletes, or whatever, or inserts inside of a transaction, it's the idea of like rolling back a transaction or committing a transaction.
Yeah, that's a great example. Great example. I'm glad you're here, Mike. All right, so AST. We've talked a little bit about this, right? And I think it's important to understand, right? You don't necessarily have to be an AST expert, but it is important, I think, to know it's there and kind of know at least how to start going down the path of using it if you need it, right? And so, an AST is essentially a representation of the structure of your code, right? Written in another programming language. So the code that represents your code, if you will. And so let's take a look at kind of what that gives you in the data that's there, right? And so on the left, right, we have a kind of a simple component, right? It has a method called login, and it takes a single argument called password, and we've specified that its type should be a string. So if we were to traverse the tree, right, and go down through the nodes and find the login method and find its constructor, right, the data on the right is what we would have available to us. So this is the arguments of the login method, right? And so we've got two of them in there, so it's an array. And so you can see the first one, if we look at the bottom of the first object, we have that escape text called password. So it's kind of giving us the raw data. And the same thing for the next one, the escape text is string. Excuse me. And there's some other information here. We saw the position, right, the end. We were using that in the update recorder. But what's interesting is that we have the kind and the original keyword kind. And this is what lets us match very precisely to the type that it is. So if we were in our editor, we would have access to the AST through TypeScript. So TypeScript provides us its AST. So other languages have their own AST. But we can see here, I'll blow this up. This is a big file, so it's kind of slow. Come on. But if we equate that number 142, the syntax kind, we can see that it's a string keyword. And you can see there's lots of other keywords in here as well. So again, we're not matching, like, is it string with an uppercase S or lowercase s? Is that the right one, right? TypeScript is telling us exactly what that kind is, right? String. And we've got object number, read only. We've got all this metadata in here. And so we would use this by importing this. This is a giant enum here. But we would import the syntax kind and then be able to key off that and do a very precise match in our schematic and know that we're getting exactly what we want, or checking for the existence of it, or however your schematic needs to use it. And so if you haven't seen this before, there's a couple viewers out there. There is, let's pull up astexplorer.net. Right, so you can pass in any code that you want here. You can also pick from a variety of AST parsers, right? So we're using the TypeScript one. And then what's kind of cool is like you can click on any of these parts, and on the right side, it will update with the node that you're selected, right? So I'm clicking the string type from password, and we can see all that metadata right here, right? The text is string, the original keyword kind is 142. We can come over to login, right? Here's the login text, all the kind information. So there's some really cool AST viewers. ASTExplorer.net is one. And another one is ts-ast-viewer.com. Obviously, this one works just with TypeScript. But what's interesting is that, let's see, it will also, if this is going to scale well. Here we go. But it'll give you some information as to like kind of how to create an identifier or a lookup function using the TypeScript parser over here on the right. Obviously, this is kind of a bad example, but you'll get kind of the method of what you would need to call to get it while still having all the information over here on the right. And then I lost my place. Here we go. And then this is just a link to that enum file that we were looking at over here on the right. So I'll share these slides out so everyone has access to these links. So once I started writing that Jest schematic that I talked about earlier, which is kind of the first one I got into, I quickly ran into the issue of like, okay, how do I test this thing? Because like I knew nothing about schematics, and I'm like, is this thing even working? What I was really wanting was that ngServe experience. I wanted to make a change, save it, and then kind of see it in action, kind of on the other side after it ran. And so again, there was that great article from Hans who kind of set a lot of this stuff up and kind of laid a lot out. And I took kind of those ideas and put some additional scripts together to come up with this kind of idea of a sandbox or a testing sandbox. And this is the way that all of the schematics I've written have been written with. But essentially, you'll have your source directory, and that'll contain all of your schematic code, if you will, that gets executed. And alongside that, I check in generally a sandbox folder, and inside of that, I basically run ngNew. So I just have a full-fledged application that's checked into source control. And then through yarn or npm linking, which I know is not everyone's favorite thing, but it's been pretty stable with this pattern here. But through yarn and npm linking, we can link our local schematic in the source directory over to the sandbox application so that I can go into the sandbox and basically run my schematic that's written locally in that source directory, and I can kind of test it out in real time. And then the scripts that I put together, they just kind of expedite that process. So you can just kind of run one command and it builds it, executes it. You can run tests, which are really nice once you get this into like a CI/CD environment. So I have generally will just run like a production build or the sandbox unit and end-to-end tests to make sure my schematic hasn't totally broken everything. But then you can kind of get into this really easy, pass-fail scenario within CI/CD. And the nice thing is that since we are checking the sandbox into version control, when we execute our schematic, we can use our git diffing tools, depending on what editor you're using, and quickly see like, okay, what changes did my schematic make from the sandbox's original state? So if I'm adding a bunch of files, I can just look in the git diff tool and say, oh, it added these 4 files and they're named this way. Or if it modified a file, I can go and say, oh, it changed, it added this method or rename this this string name, right? So it makes it very easy to kind of get this kind of fast iteration approach to writing your schematic, either running a script or you can use watch mode, if you will, and then waiting a few seconds for everything to compile, just like the Angular CLI, and then you will see what changes that it made to the sandbox. And so I found that to be very helpful and very easy to learn schematics, because I can quickly see like, is my schematic doing what it's supposed to do? And I found that quite helpful. Though it is not the only way to develop a schematic, you can obviously take the unit test approach as well.
Kevin, I know you can't see the chat in YouTube because you're busy, but Fergus said he browses AST like it's a normal human ability.
That I do not. I do. I do not do that. I spend plenty of time not, or I guess, Googling things, looking things up, looking for all the syntax kind methods. But I would not call myself an AST expert. I'm working on
Make it look easy. Well, between you and Mike, at least you guys are at least one, maybe two AST
yeah.
experts.
Well, it's just the slides. It looks easy on the slides, but I spend plenty of time trial and erroring with the AST as well. So
he's so modest. Just say I woke up like this, Kevin.
I wish. Trust me, I wish. So yeah, I have this kind of sandbox idea, right? If that's something you want to do, it's again not the only way to develop a sandbox. There's other approaches that check in an application to source control and do it different ways. But this way's I found it to be pretty nice. The scripts are kind of all there. You can basically just run yarn test or npm test, and it just builds, runs, tests all in one script, and you get that visual feedback kind of instantly. And so at my GitHub, there's a schematic starter repo, and you can clone that down or fork it however you want to do, and change a couple things like just basically the package names. I've kind of got that all listed out in the README, but you can kind of get up and running instantly with this sandbox and start writing code and have all the scripts set up and the linking and whatnot. So if that's something you're interested, I put that out there as well. So that's kind of concludes the slides I have. I started thinking about all these things we were talking about, and I put together a blog post, which we can share out. But it just kind of outlines some of the things that I use on a daily basis or have found really helpful when learning schematics. So I've got those AST explorers, linked to the syntax kind codes. So if you're not in your editor, you can go and look that up. There's some really nice manipulation and navigation libraries like TS Query and TS Morph, right? And some of those are ports of other AST libraries, but they can make working with the AST a lot easier. So for example, TS Query kind of lets you use a CSS style selector pattern, if you will, to kind of access things or search for things, which is really nice. And a couple other resources, for example, like the Babel Handbook, right, and Unified JS, as well as links to some of the schematics I've built and worked on, plus that sandbox approach.
Have you done anything you mentioned earlier, like say making a change, with JSON to a file and then possibly running linting on it or something? Have you done anything with that in schematics where you run some other existing function or command that's not part of the code base, but an external tool?
Well, I think the example I referenced was when we're parsing and stringifying the JSON, right, it may not go back, for example, with the same indentation level that their code usually have, like let's say 2 spaces versus 4 spaces. And so in that example, I was kind of referencing, there's a method to execute the TS-lint rules for that specific project, so that however the project is set up, it'll just kind of reformat the code based on each individual project's settings. So that's the example I was talking about, but you're talking about an external script, is that right?
Yeah, or even like in that scenario, like if you're creating that schematic to do that change to that file, and you want to, in your schematic, say, I want to make TS-lint run or the linting rule run, like how would you program that in the schematic that you're creating to run that? Is there a helper function to do that? Is there that schematics provides? Is that, that's really...
Yeah, there is a helper method, and Mike, you might know it because I don't remember offhand what it's called, but I believe there is one.
Yeah, there are some tasks that you can do, but to be clear, so as Kevin mentioned, these things run in memory, and a lot of the tooling that you're going to find surrounding JavaScript in general is going to be file based, which if you call a tool, I don't know, say, I don't know, Webpack, for example, whatever it is, some sort of build tool, what it's going to do is it's going to start looking on disk for files or whatever tooling is. A lot of them look based off of the file system, and being that it's working off of an in-memory virtual file system, those tools aren't going to work as they typically would. So either those tools need to expose ways of working with text-based or string-based representations of those files, or you're not going to be able to run those within the concept of schematics. Just because of the nature of the execution context of how your code is running and what it's running against.
Yeah, good point.
So the idea of like TSLint and things like initializing a Git repo and doing an npm install, those types of things. Schematics provides the ability to say, hey, I'm going to let you schedule some tasks to be done when the schematic is done running. So if you go ahead and are saving your the package JSON, so you add a dependency, you add an npm script and you want to reformat that and you want to run TSLint, you can basically have your schematic set up that task to run at the end, to run TSLint with the appropriate rules to essentially restyle that when you're done.
Yeah, that's a good point. Because like when you add, let's say, dependencies to the package JSON, there's a script that's kind of like you said, Mike, schedule, an npm install at the end, right?
Correct. Yeah, because you want those things to happen after you've synchronized your changes back to the actual physical disk.
Mm-hmm.
Now, what about tying in like maybe external calls or asynchronous calls? I know there's been talk before about thinking of the concept of maybe my templates or some decision-making lives on a server somewhere, and my schematic in the time that it's setting up the files would make this external HTTP call to get some additional data to then do its work, right?
Yeah.
How does that play out? Or is that something that's possible?
Yeah, definitely. Fortunately, the rules that are returned in a schematic, right, they accept a couple different types, and one of those being, well, let's say a tree would be kind of the synchronous version of that, right? You make the changes to the tree, then you return it. But you can also return an observable of that tree. And so you can pull in any of the RxJS, magic or operators that you want, and essentially, hold up the schematic, if you will, and run any sort of asynchronous logic that you want to need. So if you need to call out to a server or a database or check npm, I think I have an example of that right here, actually. So if I can find, this one's in progress. I definitely have an example here of but yeah, in a couple of mine, I actually ran across this because I wanted my schematic to go and get the latest version of a package from npm. And so I wrote a rule that returns an observable of a tree, and it basically takes the string package name, calls out to npm, gets the latest version, and then it inserts that in the package JSON for that version. So it kind of calls out to npm, gets the version for a couple packages, brings in, and now I have the latest version of that package for my schematic, and I don't have to essentially pin a version at my schematic and keep, making releases to update that version. I just say, well, just go out to npm and get whatever the latest version is, and then add that in the package JSON, and then the npm install command will just run its normal install for whatever the latest version is. Now that might not be the right example or the right use case for every schematic, but if your schematic doesn't depend on exact versions, or you don't want to necessarily support exact versions, take that risk of just running latest, right? You can have your rule return an observable, and then that observable can do whatever it needs to do asynchronously.
Nice. All right, anyone have any last schematics, questions, points, or are we ready to wrap up? Say now, forever hold your peace.
I like your schematic starter repo, Kevin.
Thank you. Thanks.
All right. Well, let's do some picks, and then we'll call it an episode. A panelist. Does anybody have any picks today? Bonnie does. First, hands up. You go
Am I
first.
allowed to have 3 if I go really, really fast?
Okay.
Okay, NG Houston, today we had Isaac Mann with NX Workspace, a brand new course from Narwhal. That was pretty cool. Check it out. Shout out to the Belgium Angular crew at NGBE next week, which is super exciting. And you guys, I'm really excited because our friend Shorty put all of the upcoming episodes on the Angular Air so that you can go. So we have Kim Maida, we have Naomi Meyer coming, we have Gil Pink, we have Ilya, all of these upcoming guests on Angular Air, and he loaded them all up. So you can actually go and click on the Angular Air YouTube channel and see everything that's coming like for the next month. It's great. That's it.
And another one of our friends, Bill Odom, he got the follow-up episode added.
He's coming.
Bill's coming back?
Yeah, that'll be next up. That's coming too.
Okay. And also, did you know that you can go on the YouTube channel and you can click, if there's an episode that you're really excited about, you can click and set a reminder for yourself. Yeah.
Nice. Thank you. Good picks.
Thank you,
All right.
Justin.
Sure. All right, who else?
So I'm speaking of Brian Love from earlier. Was on a show with him earlier today. So I'm stealing his pick because I freaking loved it, and he reminded me because I knew this, but I had forgotten. Do you guys know why Ivy is called Ivy? Yeah, you do. You guys, okay. So it's because I guess it's the 4th rendering engine, which in Roman numerals is IV. So I freaking love that. That it actually, because you see like the ivy vines everywhere, all over like blog posts and things, and it has nothing to do with the plant, which I love. But I'm really excited about where I guess we're on our RC3 now with 9, and we're getting close. So I work for Kendo UI at Progress, and I actually got to like talk with the team on some issues that we were having with an early RC, and it's been fixed. And I'm just so excited about this because they were working so hard to make sure that it's flawless and that it comes out smoothly. So I'm really excited about 9.
Look at you, early adopter, Alyssa.
I always like to code name anything I start working on with some fun project name like that, and with the hopes that someday, like whatever I build will be exciting enough that people want to dig in and go, what was the code name for that? I never get
They were saying,
so all my code names just die in this little secret spot that I have, but it's always fun, I think, to try and figure out a special name for something, right?
I heard that when they first started talking about Ivy, that they were saying, because it was, the concept of it was injected view. And so the I and the V plus the fact that it was version 4 and it was like all of this, like they just I don't know. I don't remember who told me that. It might be a myth. I might have just made that up. I don't know. But injected view plus the number 4 was all just perfect.
Sounds good.
Sounds legit. Mike, you have any picks today?
No. Tomorrow's a holiday in the US, so enjoy time with family and or friends, and just enjoy yourself.
All right. Good job. Good pick. I'll take that. I saw a movie last night called Knives Out, and I'm going to pick that because that was really fun. I liked it a lot. It was a good kind of murder mystery comedy. It was fun. So that's my pick. Kevin, our guest, do you have any picks for us today?
Yeah. So first I want to give Anthony Jones's Cypress schematic. He just got that released today, what we were talking about. So he's at Anthony Jones 519 on Twitter. So you should give him a follow and check out his schematic if you want to set up Cypress with your Angular application.
You know you hit it big time when Minko is tweeting about you.
He's set. He's set.
Right?
I think.
You're officially famous now.
He is. Yeah. Well, it'll be a difficulty to get some time with him now, I think. And then last one, I was just telling a friend about this, and actually I have it right here, but there's a great book I read recently called The Code Book right? And it is about encryption. And I don't really know a lot about encryption, but this is a great book because it starts you from like ancient Egypt encryption all the way up to like quantum computing encryption. So it made it really easy to understand and see how it's progressed and really what encryption is doing under the hood. So I'd highly recommend that book. It was a really fun read.
That sounds really cool. Let's check that out for sure.
Yeah.
All right, Kevin, thanks a ton for sharing your time and coming on here and sharing this content with us. We really, really appreciate it. Thank you.
Yeah, thank you for having me. It was a lot of fun.
Awesome. All right, that's a good one. Like Bonnie mentioned, check out the channel. We got a bunch of upcoming episodes that are good and lined up, so looking forward to it. Have a good one. Take it easy. See ya.
See ya.